We are in Geometry Lesson 1-8, Properties of Dilations. Today's date is Thursday, September 10th, 2020. Wants to do the objective. Read it off. Go for it, Jade.
Dilate points and find both the scale factor and center of dilation.
There it is. And typically speaking, dilations in our class are finally the new transformation that you haven't heard about. I'm hoping maybe you have heard about it. You've always heard about rotate because the wheels on the bus go round and round type of stuff. They rotate, right? You've seen all of these properties before. This is the first one where it's like, oh, this is kind of new. I need to get my head around it. So dilation, very simply, it just means to resize the source. So make it bigger, or it could be make it smaller, and depending on if you have negative numbers, really weird things happen too, but generally just resizing. Resize the source. And then before all of the transformations that we've had in terms of translation or a move, a reflection or a mirror, and then a rotation. Did I name all three of them? I think I did. Anyway, the three that we've done previously, those are all rigid transformations, which means if I have a shape that, I don't know if you can see my camera, let me maybe stop sharing my screen really quickly. If I have a shape that's this big and I do something to it, it turns into a shape that's the same size. Now we're doing something that starts this big and it will get that big, like way bigger, or maybe I'll do something and then it gets really tiny, like it doesn't preserve the size of the shape anymore. Okay, so, and then weirdly, yeah, everything gets out of order when I stop sharing my screen, but computer, don't have a heart attack on me. There it goes. So all the lengths are just multiplied by something that's known as the scale factor. It's just a number. Maybe the scale factor is 2. It just means, hey, multiply all the lengths by 2. It's just some number. So I'll say down here, this is just some number. Okay, so we're going to be doing 3 different dilations all down here on this graph paper. So I'm going to dilate A, B, and C, but I'm going to dilate each of them in a different way, and we'll see some kind of cool properties. So by the way, I'm going to start using some vocab. So there's this thing down here called the point of dilation. In our case, our point of dilation is going to be P, because it says dilate A about point P. So P is the point of dilation. And you can always choose that to be any other point that you want. So if you have a ruler, it will help for this. So if you want to go grab one now, but you don't need one, you can always sketch it. It's not that hard to make too straight of a line. So dilate A about point P with a scale factor of 3. So what was the original length between A and P? So I'm going to do this one in blue. I'll do each of them in a different color. So this length right here between A and P, what was that original length? And I'm going to, I guess you can count right and then up, or you can count the diagonal squares, if you will. Essentially what I have is I had a change of X, that's 2, and a change of Y, that's 2. That's the original movement from P to A. To get from P to A prime, after I do the dilation, all of these delta X and delta Y's are going to be multiplied by, and you guessed it, the scale factor. The scale factor that we chose, I told you right here, I'm going to be multiplying by 3. So this delta X, which was 2, multiply that by 3, it should now be 6. So again, you always start at P and you're going to count 6 to the right. So count 1, 2, 3, 4, 5, 6. And it's going to be somewhere along this line now. Okay, and then I'm going to also count, okay, my delta Y is 2. It's now going to be multiplied by the scale factor of 3, and it's also going to be 6. Then I count up 1, 2, 3, 4, 5, 6. And where do those two combine? Chunk, chunk. So right there. So this point right here is my A prime. Okay, let's try it again. I think you guys can try this one. Like you have the basic math down, right? So far, let's do this one in red. B, to get from P to B, I'm going like this. I'm going to do a red line. I'm going one right, so I'm running out of room. But my change in X for red now, my change in X is 1. I'm just going 1 right. And my change in Y here, I'm going up 1, 2, 3, 4. So change in Y is 4. All of those are going to be multiplied by our scale factor, which is 2. So try that on your own. I'll give you guys like a 30 seconds and then I'll do it. Okay, so I'm going to be moving 2 to the right now. So I'm going to come 1, 2, and then instead of going 4 up, I'm going to go 8 up. So 1, 2, 3, 4, 5, 6, 7, 8, and that intersects right here. So I'll make that maybe a smaller point. It's going to be my B prime. And then finally, I'll do this one in black. We need to get C prime. And it's the same thing, it's just a fraction now. So you always are multiplying. You always multiply by the scale factor, which means if your scale factor is between 0 and 1, if it's like a fraction, like a half or 2/3 or a third or a fifth, something like that, you're really dividing, right? Like multiplying by a half is the same thing as dividing by 2. So I'm going to find my change in X, find my change in Y, and divide both of those by 2. That's the same thing as multiplying by a half. So here we go. My original line, this distance right here, my change in X is 1, 2, 3, 4. My change in Y is 1, 2. So I'll say my change in Y is equal to 2. And I need to take half of that distance. So half of that distance is 2. Now you always count from P. So 1, 2. Half of the change in Y is 1. And it's going to be, oh, it's a point that was originally on the line, which is kind of interesting. So this black point right here is going to be my C prime. There's a way to check. Oh yeah, go for it, Kira.
I just gotta warn you that like the B prime and A prime are kind of in the middle of the words.
Oh, okay. I mean, it's fine as long as you can see it. You're good. So there's a way to check if your dilations are correct, or at least if they might not be scaled correctly, but at least they're in the right direction. The way that you can check, and this is what this block of text over here is talking about, the point of dilation, which is the source, and the image. So in this case, like if I'm looking at A and A prime, I'm talking about those 2 points, will all be on the same, this word means collinear. So Esha, do you have a question? Or
my question though is, so for finding point C prime, all you did was halved it because it was being multiplied by a half?
Exactly. So if I'm looking at my delta X, which was 4, I'm really saying I'm multiplying that 4 times my scale factor over here of a half. So times 1/2, which is the equivalent of saying 4 halves, which is 2.
Okay.
Yeah. So every single time you're just multiplying over and over by whatever the scale factor is. And if you are tricky about how you do multiplication, it's really division in the right circumstance.
Okay.
Good question. Yeah, Charles, did you have the fill in the blank word?
I think I do.
Yeah, go for it.
I was gonna say on like the same plane or grid.
Well, I mean, hopefully everything is on the same plane or grid. We're looking to make sure that it's collinear. Do you see this word right
So
here?
like, yeah. So, oh, it's all on the same line?
Yeah, exactly.
Like from the point to point?
Yeah, so here, I'll show you guys what I mean. Check this out. And I know that not everyone has graph paper, so it might be a little bit off, But if you scale it really close to what it should be, if you draw out the line, let me do the shape. Look at PA. I'm looking at this line right here, PA. If I extend that line and I don't change the angle, I don't randomly go off in a new direction. If I continue the line in the same direction, what should theoretically happen is it goes through that point and continues out through A prime. And then same thing for B. Like to get from P to B and then to B prime, it's just a line that extends through that point and eventually hits B prime. They're all on the same line. And then we already know that C and C prime are on the same line because it shrunk and was on the same line.
So like it won't, I guess, be correct if it was off of the line. It wouldn't be a dilation, or
Exactly, it's not a dilation. So for
Okay.
example, if I've somehow found A prime to be right here, that's not a dilation. It has to be somewhere on that line. I can't have anything off the line anywhere out here. It has to be on that line. So it's a way to check your work, and it's a way to verify, yeah, it is indeed a dilation. And this is going to help you go in the reverse too. Eventually, I'm going to be giving you a dilation, and I'm going to be asking you, hey, where is the point of dilation? You'll have to draw all the lines and see where the lines connect, because check this out too. If you're looking ahead, which is the next side of the notes, if I didn't have P, and I didn't know that P was down there, but I knew where A prime, A, C prime, C, B prime, B, all those were, if I just drew lines through them, they do eventually intersect over here at the point of dilation. So you can go in reverse as well. Okay, so let's do another example. Triangle A prime, B prime, C prime is the image of triangle ABC under a dilation. I'm now asking you, what is the factor of dilation? What do they multiply by over and over again? And obviously you can't see what the point of dilation or the point of dilation is not even on the grid. But what factor are they multiplying by? They started with the blue triangle, then they dilated it and it turned into this red triangle. What is the factor? And again, every single length is always multiplied by the scale factor. So we need to find some length. I'll let you think about that for a few seconds. I'm going to give a few more seconds for people to think. Yeah, Ulysses, go for it.
Would you like could you do like C and B and count those points and like see from like what that amount of spaces went to from C prime to B prime?
Exactly, yeah, that's our strat. So, and I'll explain it in a different way too, in case you guys didn't catch it. It's really difficult to count how far we went from A to B, because that's a diagonal length. The only way that we can do that, and eventually you guys will find this if you haven't figured this out before, is you have to use Pythagorean's theorem, which is a bit of work. Same thing for A to C, this line segment. The only way to figure out the length of that line segment is to use a bunch of math instead of just counting. So Ulysses has the right strategy. Find the ones that go horizontal or vertical that you can actually count the number of squares, and then we can compare the two. Okay, so yeah, the distance between C and B, this line segment is 4 units long, and then line segment C prime, B prime, that's 3 units long. So we still haven't answered the question though. We're almost there. What do we multiply? So another way of asking this is, what times 4 gives us 3? This is, remember, anything that we multiply the original source, yeah, I'm thinking the right word. Anything that we multiply the source by to get the actual transformation, that means that this x is called the factor of dilation. So this x is the factor of dilation, or dilation factor, whatever you want to call it. What is that thing? And you can now solve it, right? X times 4 is equal to 3. What do we do to both sides? You guys got this. This is like Algebra 1. We've already passed this in our Algebra 1 class from before. Yeah, I haven't heard from White yet today.
Would you divide each side by 4?
You do indeed divide each side by 4, so divide by 4, and therefore x is equal to 3/4. Cool. If you're curious if there's a more systematic way that will always work over and over again, there is. And I hate giving formulas, and maybe one year I'll test it out and see what happens if I never give formulas, if you guys still can do it. But for now, I'm going to go ahead and give you the formula in case you need it. Here it is. Scale factor is equal to your image, sorry, the image, so the primes, right? The image length divided by the source length. And if you don't like the words image and source, maybe you want to say it's the new divided by the old. So this is the same thing as saying new divided by old. Let's try to be as technically correct as we can, because geometry is that class where we have this transition into formal proofs and being very, very maybe pedantic. But yeah, it's the image length divided by the source length. And check that out. So the image length in this case was 3. The source length was 4. So just do 3 divided by 4. Yeah, that's the answer. That's how we got it. This will work all the time as long as you can find the original length to plug into the formula. Okay, so let's move on to example 3 then. And you guys, at any time, if you want to just raise your hand and be like, hey, I need to copy some stuff down. I'm trying to leave as much up on the screen as I can. But yeah, just let me know to slow down if you need it. All right, so example 3, triangle A prime, B prime, C prime is the image of a triangle ABC. Notice that they gave us triangle ABC. They did not give us triangle A prime, B prime, C prime, so we don't know where that is. And triangle A prime, B prime, C prime is the result of a dilation with a scale factor of 7/2. So giving you some fractions now, see how well you can handle it. My question for you is, what is the length of the segment BC? What am I gonna do here? So I'm gonna give you guys at least 10 seconds to think about this problem. We need to change this problem because there's a typo. This should have been B prime, C prime. So, and I wrote it in my notes, but it's so small that I didn't see it, so I'll make a note for next time. This is a mistake here, Mr. Sandell. Catch this for next year. It should be B prime, C prime. Because otherwise, we know the length of BC, done. You just count the squares, right? It's that easy. Finding B prime, C prime, though, the thing that's not listed here on the shape, that's a little bit harder to do. All right, how many people have an idea of how to start this one, or just the answer, anything that they're ready to volunteer? Only 3 people. Maybe I didn't give enough wait time. But I haven't heard from Kira yet, so let's talk to you, Kira.
Okay, well, I think you have to do 7/2 times 4 because there's 4, the distance is 4 between B and C. No, I have to remember how to do fractions. Can you just make it 4/2 times 7/2? Or 4 over 1?
Yeah, 4/1 exactly. So times 4/1.
The 2 and the 4 cancel out, so it's 7 times 2 equals 14/1. So I guess the answer is 14. The length of line segment B prime, C prime is 14.
Yeah, done. There it is. Well said. You sounded like you were very hesitant throughout the whole process, but everything that you said was correct, and you did it really fast too. So, I mean, it's not about speed, but great job. Yeah, it is indeed going to be 14. Any questions on Kira's process, guys? No? Okay, we do have a backside question. Ashley, go.
How did you get 4/1?
Great question. Kira, it's you.
Well, every number, if you need to multiply it by a fraction, you just put it over a 1 and it's still 4. It just means like 4 is the whole number. You just put it over 1.
So you got 4 from the distance between B and C.
Yeah.
Okay.
Raise your hand if you want some more time to copy some stuff down. So there is. Okay, cool. Yeah, a few people. Okay, well, it looks like I jumped the gun. I already gave you this formula on the previous side. Do you guys remember what it is? Maybe you don't. Here, try not to look at your notes. What is the simple formula that I gave you guys? And use the correct one, not the easy one, the one that is using the correct language. Yeah, Jade, go for it.
I'm not sure, but I think it's scale factor equals image source over original source? I don't know, but then
Yeah,
it's
the original.
equal to new over old.
Yeah, new over old. Yeah, and image is the new, and then the old one. You said it, but I think you're maybe
Original?
hesitant. It's source. Yeah.
Mr. Snow, could you wait a minute? I'm having some pencil problems, so I can't write this down.
Okay. Yeah.
It won't take long.
Yeah, so since we have 45 seconds, really quickly, the way that you solve these to find the center of dilation, I know that you guys are not copying this down. I'll put the video of this in about an hour maybe. Oh no, I can do it like right after this class. Is you just make a line. So obviously this point here and this point here are the same, I don't know, corresponding part. So if I make a line that connects those two, I can try a better line like that. So it looks like the answer is not going to be C. It's not going to be C and it's not going to be D because this line only goes through A and B. Let's try another pair of points. So if I have a point over here and a point over here, those are the corresponding parts. If I make a line that goes through those points, it looks like it's going through, oh, so I mean, just from those 2 points, it looks like it's intersecting at A. Obviously, from M to M prime, I'm not going through B more than once. So the correct answer here is just A. That is the center of dilation. You just draw two lines, that's all you need. And you can draw a third line to verify that. That third line should also go through point A as well. And they're that easy. So I can do example 5 really quickly here, but you guys are 30 seconds now over. You guys can leave for your break if you want. I'll put the video up in a bit. So I'll see you guys tomorrow or later. So for example 5, it's a little bit trickier, but again, just look at their corresponding parts. I'm going to do a point that's right there. I don't know what's going on with my pencil. Oh, I know what's going on. Ha ha ha. I'm being silly. Go to that tool. Ha. Okay. I have a point there. I have a point there. So those 2 points are going to go through. Oh, well, there's only one option here. It doesn't even go through 2 points. So I've already eliminated A, C, and D just from one line. So this is a case where I didn't need to do 2 lines. I just need to do 1 line, and I have my answer. The correct answer here is B. The end. Done. And I'll write this for the notes too. What we're doing is we're drawing a line from corresponding, which is a fancy way of saying matching the right part. Corresponding source and image. I'll put in parentheses points usually. I mean, you could do it for the lengths if you had some sort of indication of where those lengths corresponded, but technically we only really have points marked out. And that's it. Yeah, that's the end of the notes. I'll stop the recording.